Okay, so we have to convert a transmission line operated at 3 GHz frequency with velocity of 77% speed of light into a 2 picofarad capacitor and 5.3 Henry 5.3 nanohenry inductor. So always remember this point is the open circuit point, the right hand side point, and the left hand side point is the short circuit point. So first we have to find the impedance due to the inductor, sorry, capacitor. So C is 2 picofarad, F is 3 GHz, XC is 1 by omega C. Omega, we know the frequency, which is 77% of that of speed of light, and we get the impedance is 26.52 ohm. So this is the frequency, not the speed, 3 into 10 power 9. Then we have to normalize the impedance that we have got up with the characteristic impedance, which is 50 ohm. And we can also find the wavelength. So at last we have to find the distance in terms of wavelength. So basically we need to multiply with the wavelength. So this is the velocity, it's 77% of speed of light divided by the frequency of operation. So we get the wavelength at this 0.07 meters. Next, mark the point 0.53 that we have got on the SmithChart. Since it is a capacitor, it will be negative and it will be below. Since we have to convert the transmission line from open circuit, so from here the point, the angle is 0.25. From here we have to find the angular distance till here. So the distance if we subtract is 0.1 in terms of wavelength lambda. So I've subtracted that. This point, if we subtract this point minus this point, you get 0.172 lambda. Next, to find the distance, you just have to multiply with the wavelength and you get the distance is 13.24 millimeter. Similarly, to convert it into an inductor, find the impedance of an inductor, which is given by this formula, and you get impedance with this, normalize it with the characteristic impedance. So we'll get 100 divided by 50, that's 2, and wavelength will be already calculated, that is 0.007 meters. And okay, yeah. So inductor is basically, it has positive impedance, so it will be marked over here, that's 2J. And from here we have to find the angular distance till here. So from the center point, draw a straight line, and you can basically this whole circle has an angular distance of 0.5. So it basically starts from here, and over here it is 0.25 lambda, and it will end over here with 0.5 lambda. So basically we are moving with of lambda by 2 distance. So to calculate this distance, you have to subtract this, as we know that this will be 0.5 minus 0.25, that's 0.25 lambda, plus from 0 to this is around 0.176 lambda. So this total distance will be 0.25 plus 0.176. It's around 0.426 lambda, and if we multiply with the wavelength, we get this distance.